Good morning, everyone. Today's workshop will be on introduction to Linux. The objective of this presentation is essentially to make you comfortable with Linux command line. As you know, CAC has a HPC cluster, and not the only way, but a good way to access these clusters or any of the supercomputers is through Linux command line, essentially to make you comfortable to work on the cluster. We will be using the frontneck HPC cluster, but if this exercises can be done anywhere, even on your local computer, if you have a Linux machine. My name is Rakesh, and I am currently a user support analyst at CAC. A bit about CAC before we start the presentation. CAC, like I said, supports research community by providing innovative digital infrastructure. One of the main resources that we provide is the HPC cluster, high performance computing cluster, but we do have several other resources for digital infrastructure, like highly secure computing and so on and so forth. Frontneck, the HPC cluster at Frontneck is not the only cluster in Canada. We come under a overarching umbrella of Digital Research Alliance of Canada. Under that, we have several consortiums based on where they are located, and we come under Compute Ontario, and CAC has a small cluster for itself as well, which is available to any Queen's researcher. If you have a PI, you can apply for an account through your PI to access this cluster. That's a brief introduction about who we are and what resources that we provide. If you have any questions, you can always email us at cac.help. Without further ado, I'll get started with the presentation. To begin with, I'll give you a quick overview of the Linux operating system. At the like most things in computer science, everything is divided into abstract layers. At the bottom of the layer, you have the hardware layer, which is the actual physical hardware that you have. It could be the CPUs, memory, hard disk, keyboards, and mouses that you're using to communicate with your system. On top of that, you have the Linux kernel, which essentially communicates with the hardware. If you type a command, probably Linux kernel will send that command through your keyboard to do some operation on the CPUs, or allocate memory on RAM and so forth. Or you have device drivers to communicate with your printer and so forth. On top of this Linux layer, you have the user space. This is where most of the users work on. Only very few few people actually work on Linux kernels, but what we work on is in the user space, either through a graphical user interface, or if you're using through a command line through a shell. This presentation, for the most part, will be focusing on using a shell to essentially communicate to the operating to access the operating system, Linux operating system. And along with the graphical user interface, that if you have one, and the shell to communicate with different applications, there are also different applications that are installed on your on a Linux system. This could be the applications that are installed with the user itself, could be R, Python, or compilers. If you are using MATLAB, this is the layer where you're installing it, and so on and so forth. One thing that I want to specify in the user space is we have something called GNU utilities. These are some of the commands that are utilities that we can use through a shell to communicate with the Linux kernel. And most of the time that I'll be spending in this workshop is to essentially make you comfortable with the command line interface, and most of the utilities that we will be using are GNU utilities, something like ls for listing all the directories or files through a shell, through a bash shell to be specific in this case. A bit of a history on Linux, like Linux is actually a Unix-like system. Unix was first initially developed in 1970s by Dennis Ritchie and Ken Thompson. This was a proprietary software for a long time. So there were some people who are working on an open source version of it, like to make it more freely available to the end users. And the Linux kernel that we saw in the last slide was developed by Linus Torvalds in 1991, and Richard Stallman developed many of the GNU utilities which are integrated into the Linux kernel. And if you, that's a brief history of Linux. The kernel itself was developed in 1991, and GNU utilities are integrated into the Linux kernel. So when you talk about a Linux system, Linux operating system, what we are talking about is the Linux kernel, the system library utilities, and any pre-installed software that are packaged together. In most cases, if you are using Ubuntu or Debian, you have a graphical user interface, and everything combined together, we call it as a Linux operating system, which is different from Linux kernel. There are several different flavors of Linux that are available, and some of you might be aware of this. We have Ubuntu, which is most commonly used on general applications. Like if you're new to Linux, probably that's one of the distro that is widely used. And but all the supercomputers and most of the supercomputers run on Red Hat Enterprise based Linux, and we use an open source version called CentOS, which is kind of end of life at the moment. So people are shifting to another flavor called Rocky Linux. If you see different various flavors of distributions of Linux, what they are is a particular Linux kernel. On top of that, you have the GNU utilities or some utilities with some pre-installed software, which are maintained in a repository by that distribution providers to cater to a particular user database. For CentOS, for example, CentOS and Red Hat, these are mostly enterprise-based, and Debian are mostly for home users. In fact, when I first started using Linux, Ubuntu is the system that I went to because of the nice graphical user interface and things like that. A Linux distribution doesn't necessarily need to have a graphic user interface, but if you are installing on your home computer, probably you can install a graphical user interface. But in order to access a supercomputer, essentially you want to access it using command line because there are certain limitations for when it comes to graphical user interface. There are some advantages as well. This slide shows a comparison between graphical user interface and command line. What it essentially has is a graphical user interface. If you are using any of the Windows machines or things like that, it's very easy to use and get familiarized with in the beginning. It does come with a lot of pre-installed softwares, for example, Libre or Firefox that you will be using, you might be using for your on a daily basis. Graphical user interface, to its credit, is very good at using the existing functionality, but there are certain limitations on using. It gives you less control. What is given to you is what you can essentially use, but not beyond that. And it's also not ideal for a remote server because rendering the graphical user interface onto your computer can be quite slow, and there is a large overhead that needs to go through the networks, which can which can limit your user experience in that sense. In comparison, command line, when you're first beginning with it, it can be quite hard to learn. Essentially, when you log into a cluster, which we'll be doing in a short while, essentially you're given a blank canvas, and it can be overwhelming in the beginning to essentially navigate through this. We have to acknowledge that. But the command line has several commands that are efficient in doing one thing, and it can be useful in creating reproducible work and repetitive workflows. That's what you need when you're conducting your research, and if you want to rerun the simulations that you're running or recreate the workflows that you're creating, command line or scripting is a wonderful tool to do that. And it gives you a lot of control in what you can do. But there is a huge steep learning curve that you need to pass through to get to that. And for the most part, on most HPC clusters, like high performance computing clusters or supercomputers, this is the most simplest way, I would say, to access the system, which gives you a lot of flexibility. You can access it. There are some VDI nodes and some graphical user interfaces that you can use, but the amount of resources that are usually available on supercomputers for these kinds of setups are limited. And if you want to use the full infrastructure that's available through a supercomputer or any service, for that example, it's always recommended to get comfortable with command line. And most of this probably you are already aware of. That's probably the reason you are here. That's something to keep in mind. To begin with, I'll start with a quick demonstration of a Linux operating system. If you are coming from a Windows environment, this can be quite different from what you see in a Windows, or probably if you're using Mac, probably it might be more similar because it's a Unix-like system. But if you are coming from a Windows system, the first thing that you notice is there is no C drive. So I'll quickly give a demonstration of how a GUI interface for an Ubuntu system looks like before we get started with the presentation. So I'm using a virtual machine on top of my Linux machine over here, and I'm going to quickly start. So when you log in, you see a login screen similar to what you see in a Windows machine. You enter your password. And first screen you see will look something like this. And first thing that you'll notice when you're using the system is if you open the directories in Windows, you have your C folder where you have your system files, and if you have additional partitions like D or E, that's where you save your user files and things like that. That's not available here. If I go to other locations over here and have a quick look at what's available, and if I go here, I'm at the root directory, and you see a bunch of folders in each of these systems. So what I can see over here is there is a bin directory. I will go over each of these directories in a short moment, but when you log into a cluster, where you land is your home directory, and each user has a particular folder in their home directory, and probably when we log into the cluster, this is where you land. For example, if I open a terminal over here, here I'm on my HPC cluster, and if I if I'm here, like this is where I land on, like this is my home directory, and there are certain commands to make sure where you are and what you're doing over here. And if we go into the Linux system, if I go to the root directory, you have a bunch of folders here. One thing is the bin directory. This is where all the system GNU utilities are stored. All the most of the Linux commands that you'll be using are stored here. And everything in Linux is a file. Like all the files that you store are files. So then you have boot directory. This is probably the files that that the system uses to boot the Linux operating system. Then you have device directories, which are files to communicate with the devices that are connected to your system. It could be your printers, it could be your keyboards, and so on and so forth, etc. etc file is some system scripts that are available, and there are two other folders which are kind of important, which is lib32 and lib64. These are your system libraries. If you are compiling it C code or something like that, this is the place where you have these libraries that you can use to make your applications. And then you have user directory, which contains the applications that are installed for the users itself. If you are installing MATLAB or Python or things like that, probably is the place where it's installed. And there are a few other directories such as var, which is for log, to keep all the log files. The system keeps its log files over there. And there is a temp directory, which is a temporary space. You might not, when you're first new to the system, you might not need all these directories that are available. But what you'll remember is there is a home directory in the root, and there is a temp directory. Temp directory, you can use this temp directory provided there is space to run your applications. Like essentially, these are the only folder in the root directory where a user can create their own files. This is useful when you are using the HPC cluster, because the storage in a HPC cluster is connected through a network, and which can, the IO operations can walk down the network speeds and things like that. In that case, you can use temporary directories, transferring your files that are needed for your simulation to temporary directories and run your simulations over there. That gives a quick overview of how a Linux system looks like under the hood, like a Linux file system looks like. This is the same thing, like represented in via diagram. You have your root directory. Under these root directories, you have different folders, and each of these folders have different specific files that are installed in there. For the bin directory, like I said, these contain the system executables. This includes the GNU utilities and so on and so forth. Lib files contains the library files, and you have user bin. That's where all the applications are actually installed, and so on and so forth. And when in your user space, what you're concerned, or what you end up when you log in, is the home directory. And in the home directory, each user gets a file, a folder, and that's where you can create your files. You can install your software that you can want to install locally, and save your scripts and so on and so forth. Everything that you do is probably in the home directory or project directory that we will be seeing in a bit later. This gives a quick overview of what these each directory contains. I briefly went over this in the previous slide, but I'll leave it here just for reference, and I'm not going to go over each of these steps. This will mostly be a hands-on workshop. So this is a quick overview of how a Linux file system and a Linux operating system looks like. And with that, we'll go, the way we access the Linux operating system is through a shell. And what shell is, it's a super program. And it's an interface, like if you have seen, like we have a user space and a kernel space. And essentially, the shell is an interface between the user. As a user, you can run commands to talk to your Linux kernel, which in turn talks to the hardware to do your computation or to display to your screen or take input from your keyboard and so on and so forth. Almost all computers these days, like even on Microsoft, has some sort of shell program installed on it. If you are talking about Linux or Unix-based systems like Mac OS, you have something called terminal. And when you open a terminal, like you will be given a particular shell program called bash shell, which is by default in most Linux systems. And if you're using Microsoft Windows, like there is another shell program called PowerShell, which is a more recent addition compared to what we have in Linux. Apart from that, like if you can either use a terminal to open a shell program, or you can use it terminal emulators that are similar to, which gives you the interface that you need, similar to a Linux terminal or a Unix terminal. There are several different Linux shells. You have SH, which is Bourne shell. You have Born Again shell, which is kind of a pun on Bourne shell, but this is the most commonly available or the default shell then when you open a terminal in most Linux systems. I say most, but not all. It's the default in most GNU-based operating systems. So with that, we'll start with the quick exercises. So the way you can access a Linux terminal is through a couple of things. Like either you can use a terminal emulator such as MobiXterm, and if you're working on Mac or Linux, you can use something called terminal program to open up a shell. I will quickly show you how it looks like from a MobiXterm or a terminal. And Windows also have something called Windows subsystem Linux, which is kind of a VMware running on top of Windows operating system. When you first, so the first exercise we'll have, able to see the chat. Just give me a second. If you have any questions, please feel free to post it in the chat. I'll check them on a regular basis, or the host or my support team will let me know if there is a particular question that needs to be answered. With this, that's enough about the theory about the Linux operating system and the GUI interfaces and things like that. Right now, let's get started with the actual exercise. This will be more of a hands-on experience, so like workshop. So it's not opening, and I need to. There was a question in order to gain access to the HPC cluster, you might have gotten an email saying that like you have to retrieve your password from somewhere. I received an email, someone message saying that like they can't open the login website, login.cac.cleansu.ca. Let me check if the one thing that might be happening is, are you within Canada, or are you outside Canada? That could sometimes limit the accessibility of a couple of or if you are on VPN, that can be tricky because that's tricky because Frontend cluster on all our systems are only accessible within Canada. we apologize, this is for security reasons. And if you are either accessing from away from any other country other than Canada, you need a Queen's VPN or some system that you can access that in Canada to log into the cluster. So probably that's the reason. Like if you have Queen's VPN, can you like start your VPN and use that? Okay. So what we will be using is, for this workshop, we'll be using mobile system. You are free to use any terminal that you want. But since most people will be on Windows, like I thought we'll be using mobile system for now. Just as a welcome poll to get you started, like I have prepared a short poll. I can there are a few questions in the poll, like depending on like what your experience is with the systems that you're using. If you can fill the poll, that gives me an idea of what each one's experience is with the system, and like you can answer a couple of these questions. So the most likely, like which operating system do you use on a daily basis, and have you used a command line before, and which terminal have you used before? Like this also helps me in making this workshops in the future as well. Okay, from what I see, quite a few people have used Linux, at least two or Unix-based systems, and most people are using Linux. Are using Windows. That's what I was expecting. So like if you're on Windows, what we can do is you can go to a website called Mobile Extern, or you can do it on PowerShell as well. I don't typically use PowerShell, but I'm pretty sure you can access it using the PowerShell as well. Oh, I'll show it using the PowerShell. Probably most people have it. On the PowerShell, like before you log into anything, like if I can't get my password, it says the internal server error occurred. I've seen this message before. Let me check. I'll quickly show you how to reset your password. If there is any issue, like we can just look into that. So I have you are sent your username, which is SA130. It starts with that and followed by 3 digits minus SA130101. And hopefully, one thing is, Alex, make sure your username and the email that you're sending matches. So that could be one of the reasons where you encounter system internals. So you enter your password, like this link was sent to your email, like regarding the course activation. And there's a capture. Okay, when you submit your query, you should see that you get a message saying that like a password link has been sent. I see. Oh, perfect. So yeah, it starts with SA130 and it goes on. Oh, sorry. Sorry about that. I'm not sharing my screen. So can you see my screen now? So I'll redo it again. If you go to this web page, you have to enter your username and email that you use for registration. My email is 10101 and RS. That's my email. This is the email that you used during your registration. Like if they don't match, essentially, it will give you an error. And once you click the CAPTCHA and submit a query, you will receive a message saying that an email has been sent to. Quickly do that. An email will be sent to your and I see the email over here. Once I click the image over here, that will essentially give me my password. I will not show my password, but like if you click on the link, it will be an alphanumeric password. And you should see something like your new CAC password is so on and so forth. And now I'll try to log into the cluster and say SSH, your student name, 000, at login.cac. This information has been provided in the email as well. You can have a -y flag, which essentially says that if you are running an application that needs a graphical user interface, you can actually have it to get that. Yes, the recordings of this meeting will be sent. And when I log in, now I have to enter my password. One thing that confuses people when they're first starting with the Linux command line is when you enter your password, nothing shows up. I'm right now entering something, but you can't see anything on the screen as opposed to what you see in a particular GUI interface, but the password is being entered. And I click. Hopefully I don't have any typos. Yeah. So I entered my password and I'm in. And next, what I see is I'm not sure if it's visible. Like it says because you are logging for the first time, it asks for your current password, which is still the same, and then it prompts you to enter a new password. So like you have to re-enter the password again. This is mostly a Linux thing. EMSPEIO. Oh, someone asked me how do I get to the screen. Or if you are on a Windows machine, you can use any of the terminals that you want. If you are on your Windows machine, you can hit the Windows icon and you can search for PowerShell. And once you open the PowerShell, this is the window that you'll see. Does that answer your question? Here, and if you enter PowerShell, and if you click on the PowerShell, that's the window that you see. Reloops again. DZ. And then you have to re-enter the password again. Once you enter your old password that is given, you have to enter your password twice, once to log in and once again to change your password. Once you log in, you are prompted to enter your password. This is this you only see this the first time you log in. I will give a new password. And you will be kicked out of the system, but your password has been updated. Now you can just log in with the new password. So there was a question on how do I sign up? If you have registered for this course, like you are already signed up and you have a username, you must have received an email with title called CAC account activation, and and there is a username over there which starts with SA130. Give me a thumbs up, like if you are able to log in. Like I will give 10 minutes or so for everyone to log in, and from that we can get going. Next, from now on, we will be doing all the hands-on sessions on the cluster itself. If you choose to, you can still do it on your own machine. That's not an issue. Like if you have some access to the Linux terminal, like I would recommend MobiXterm at least for this. I'm not sure how it will work on PowerShell, but it would be ideal to do it on the cluster itself. Okay. First, once you are there, you want to know like how to navigate like your system essentially. What I can do is okay. I have my presentation on one side and the Linux command line on one side. So initially what we'll be exploring is to find out where you are and just to get a feel for the Linux command line. Once you log in, if you are new to the Linux command line, you're essentially you don't know. It's a blank canvas right now, and you don't know where you are and what to do. The first thing we'll do is like we are in our once you log in, like I mentioned, we'll be in our home directory, and we'll explore what files do we have in our home directory, and we will go to the. In the beginning, I have shown that how the Linux file system is set up. So we will go into the login nodes root directory and see how the file system looks like. The initial first command that I want to mention is pwd. I will also post the commands as I go through in the command line if someone wants to copy paste it. pwd starts for present working directory. That essentially says where you are on the cluster. If I type pwd over here, it says that on Frontend cluster, all the home directories or all the global directories starts with global home or global project or something like that. This is just to distinguish that these storage is not local to the computer that you're working on, but it's on a network connected thing. But all your files and everything can be stored in this particular folder. Essentially, pwd global, that's my home directory, which is essentially home, followed by my username. If I want to list the directories in here, I have one more command called ls, which says what are the files in here. Because I don't have any files in this particular system, I don't have anything here. And the last command is like you can move to different directories. If let's say if you have access to a different, if you want to go to the root directory, right? So you can change your directory of your current system to something else. CD stands for change directory. And CD, if I give the path as /, which stands for root, that will take me to the root directory. And when I type enter, when I type pwd, that essentially says that I'm in the root directory. And if I type ls command, which lists all the commands, which lists all the files and directory in the current system, that's what you see. So there is a common folder that I created for everyone in this particular in the group. So the first exercise that I want to do is, we'll just move ahead. I want this is the second exercise that we'll be doing. Everyone open the terminal on your local computer or frontnet, preferably on the frontnet cluster, and change to the home directory. If I do cd tilde stands for home directory, and list all the files that are in this particular folder. In my case, I don't have anything here. So there is one more command, for each, it's hard to remember every command that's available, every option that's available within the commands for this Linux command line, but they're very handy. So all the GNU utilities comes with the command called man, which stands for manual, and that says what the command is about. If I say man list, that shows all the options that I have, what the Linux, what this command does. It lists the directory content, then my current working directory, or the path that you specified. And there are certain options that are given here. So there's one flag called -a, which essentially prints all the files. Right now, I'm only printing, if I just type ls command, it only prints the files that are not hidden in this particular file system. Like in Linux, if a file name starts with a dot, that file is essentially hidden. So if I have the -a flag, which it gives you all the files, including the hidden files in the system. And also you have a command called L, which is a long format, which essentially says, if I navigate to a different folder, let's say I have a couple of folders in this particular directory, and I will, if everyone can cd into this particular directory, change the directory to this particular directory. I'm posting the path in the command line, and list all the files that are available over there. That will be the first exercise that we'll be doing. And if you have any questions, please do. Just enter or Control C. There is a question on how to get out of the man ls command. If you open a manual page for any command, at the bottom of the prompt, you see a colon over here, and you can type Q or Control C to exit out of this window. If I type Q, I'm exiting out. First, we'll list all the files that are available over here. If I do ls, that's essentially all the files that are available in this particular folder directory. If I do pwd, that's the directory that I'm in. Is everyone able to navigate to this particular system? Like, we'll start off slow in the terms like we'll just navigate the file system, and then we'll explore each of the commands that you might be using on a regular basis. Like these things change from user to user depending on what they're using, but there are certain commands that you need to know just to get comfortable with the Linux command line. Can you specify what doesn't work? Like, oh, this is not the complete command to navigate to that. The complete command is cd followed by the file path. In this case, I can say cd, and this is the path I want to navigate to. And once I do that, I'll probably make it full screen. So this is the command that I'm entering. And once I do that, I'll end up in this folder. The first exercise after this we will be doing is go back to your home directory and list all the files, including the hidden files in your file system. I think I mentioned about -a flag, and open the manual page and look for what flags lists all the files in the current working directory. And if you can list all the files and find all the files that are available, we can go from there. And the second exercise is on frontneck, change the directory to /global and list all the subfolders in that particular folder. If you have any questions, feel free to post it in the chat or once you log into the cluster, it doesn't matter. Like, are you on the cluster? Like, do you see something like this? Yeah, in that case, like MobiXterm or anything, like you are on the Linux terminal. Like MobiXterm is just an interface to get to the frontend cluster. Once you're there, your local environment doesn't matter that much. The question was, I'm on MobiXterm, does that matter? Like, irrespective of the terminal that you're using on your local machine, once you SSH into the cluster, it doesn't matter. Yes, the recordings of this class will be posted online. And if you're going to another class, like one thing that I want to note is we have the course material over here. If in case you need to use it, you can download this to your local machine. I'll know what's the best way to do it. But this material will be available, and how to download these files will also be given toward the end of the recording, and it will be posted as well. So you will know how to get this material also. We'll take 10 minutes for this, and probably after a slide, we can just give me a thumbs up, like if you have if you're having any issues with this, or like if you have done this, like let me know in the chat. Oh, yeah. So the course material, I put a tar file over here, like a zip file over here, and how you can navigate is like once you log in, this is the environment that you see. All the students in this class have access to this particular folder called Global Project Workshop 2023 Linux. I'll be posting that in the chat again. And once you do that, like if you list, you can see that you have this folder. I'll go over the steps in a short while to copy this to your to your local computer if you have to, if you want to keep it for later use. I will quickly go over quick tips on this. When you're there are a few handy things that you can do with the Linux command line that are really useful. In fact, I'm doing it without my subconsciously when I'm entering all the commands that I'm entering. Let's say you have a particular command that you want to enter, and let's say if you want to navigate to a particular folder, I said I want to navigate to this particular folder, right? I know that it's in global projects and things like that, but I don't need to type out everything. Let's say I type this, and if I type G and if I type tab over there, Linux gives me options of what is available with that to auto-complete my command, essentially. If I type L again, there is only one command that can go, which is global. And if I type tab again, it auto-completes for me. Same thing, now if I want to go to project directory, I see PR, and if I type like tab, that auto-completes. This becomes really handy when you're using command line on a regular basis, because you don't want to type in everything, right? This is something that's useful. When I type IN, it goes until intro because there are several available options over here. It's intro to bioinformatics, intro to Python, and so on and so forth. And if I type L, that auto-completes for me. Tristan, can you enter the command that you're entering? Can you copy paste it in the chat? Like I'll just. So this is the command that you need to enter. Oh, there's a missing X over there. It should be. Oh, I think it got copy pasted twice. So that should be the command. And second exercise that I have is you change your directory to global and list all the folders in there. I can quickly do this over here. I see global. And if I list, that gives you all the folders that are available in the global directory. Essentially, like any file system, this is a tree-like structure, right? So on top, you have global, and you have a bunch of subdirectories. One is home, where your home files are. Project directory, this is generally for the group. Let's say we have a group for this particular class, and all the class files are in the project directory, and we have created a particular file folder called Workshop 2023. And then we have Scratch. If you are using a HPC cluster, these are the three file systems that you'll be using. Home is local to the user, and Scratch is local to the user. And project directory is something that is available for the whole group as a whole. And everyone in that group essentially have access based on file permissions. I'll come to that in a bit. And then we have some software that is installed that is available for everyone, that's also installed in global as well. And a few more things while you are using the cluster, like while you're entering the commands, while you're entering the commands, you can use the arrow signs to essentially navigate between the files. Let's say I have this particular command that I entered and it had a typo. Like this is pretty obvious. You can use forward arrow, like right arrow, left arrow. Like why don't it let me paste anything in? I'm not sure. It should. It might be depending on the terminal that you might be using, but it's very unlikely. I know certain terminals that you're using, like Jupyter Hub and things like that, doesn't let you paste anything. That can be annoying at times. In that case, I think, let me see if PowerShell does it. Yeah, if you click left click, yeah, it works. Yeah, thanks, Ashwin. And also, if you're posting it in the chat, like you can change where your chat goes. Like you can post it to host and panelist or everyone. If you can post it to everyone, that would be great because everyone will be seeing the question as well. And also, like if you want to get to, you have a previous command that you entered and you want to quickly re-enter the command, you can use top arrow and bottom arrow. Like these are the two things, top arrow and bottom arrow. You can navigate with that as well. You can use SCP. Someone asked me a question like, if they want to download the course material, how can they do it? From your local terminal, you can enter this command and that will download the files for you. You have to replace the last 3 digits with it. We are almost at the first break. So like what I'll do is I'll quickly go over these rest of the few tips that we have for Linux commands, and I'll give you a quick break of 10 minutes and we can come back. If you have any questions, like feel free to stay on and I'll be here to answer any questions. Like, but we'll take a quick 10 minutes break. So you can use up arrow and down arrow to navigate between the commands that you're entering. And also there is one more command called history, which is pretty handy. If I type history, it gives me all the commands that I used in the past to a limit of 1,000 previous commands. Like these settings can be changed, but I won't go beyond that. And essentially you can, if I want, now I can just copy paste this command if I want to go there and copy paste it, right, left click, and that's about it. That's one handy thing. And if you want to run multiple commands, you can do that as well. Let's say if I want to list the files in this particular directory, I can say and ls. Let's see what. So I changed my directory to this particular folder, and then with the double ampersand, I can enter with the ls command, like I can change my directory to that particular folder and list the files as well. This can come handy sometimes as well. Just make sure you use double ampersand and not a single ampersand. Single ampersand means the process goes to the background, so you won't be able to see what's happening there. Yeah, with that, let's take a quick 10 minutes break, and after we come back, we'll work on how to create new files and how to move your files and few commands like that. If you have any questions, please feel free to post in the chat as well. I'm here to answer any questions. And if you are having any issues logging in, we can look into that particular thing as well. Okay. Okay. Jamie, is there any way we can enable users to talk, not in the chat, at least for the paper?
It was a slightly different setup this time. I'm not sure. Let me.
Oh, okay.
See. Oh, yes, I can. Okay. I think I can do it with everyone. Just.
Thanks, Jamie. If you have any questions, we are on a break, so you can just ask it. You can unmute yourself and ask it. There was one question saying that, do I type CD every time I type something? So on Linux, everything is a command. You use the utilities to these commands to essentially do different things. CD is just one such command. What CD essentially does is it changes the directory to a particular folder. So if I am, let's say, if I'm in this particular folder, right? If I type pwd, I'm in this particular file path. But let's say I want to get to this particular folder and see something, explore something or access something over there, or your program needs to access something over there. So when I type CD and this particular line, what it does is it navigates to that particular folder. But once you are there, you change your current working directory to this particular folder. And when I type pwd command, essentially it's giving me what are the file contents in there, what is my path over there, and ls command just gives me what are the files that are available in here. Like I said, CD is not the only command. It's just to navigate. CD is used to navigate the file system. It will be available on the website. Like I'll post the link to the website. Where you registered it, it's probably in the same web link, like it will be posted as well.
I got a question about the command you put up.
Mm-hmm.
So where does this send the file to?
No, you're not sending the file anywhere. Like as a like let's see what's happening in the Windows system, right? Like if I open this particular folder, if I double click and open this particular folder, I navigate in my Windows machine, right? And it says I'm in C abacus, some of the folder name. What CD is essentially doing is what we do, this particular process that I'm using a GUI interface, but what I'm essentially doing is CD C abacus. That's equivalent of that. Like I'm navigating to that folder. I'm not doing anything over here. And when I type ls, what it does is it lists the files that are available here. This is equivalent to what we see in a GUI interface over here. So when I type in, where's my PowerShell? When I type in ls, so that's essentially giving me the files that are available. I'm not changing anything at this moment. Does that answer your question?
Sorry, I was asking about the SCP.
Oh, SCP. Okay. Oh, okay. I will go with the SCP command as well. So I will open one more window. So if I see SCP, oh, that's a good point. Like you can type probably pwd if you're on your PowerShell, and that's where you are at. You can use the very similar commands on the PowerShell as well, if I'm not wrong. If I change to documents and pwd, that's where I'm at. And I can say pwd. So it's whichever folder that I am in, like this particular thing indicates that it's the current folder and it's downloading it to that particular folder. So if I go to my documents, probably I'll see it somewhere over there if it has been downloaded. Of course. Does that answer your question?
I think so. Thanks.
Okay. There was one question called how did I autofill? So this is one of the tricks in when you're using Linux command line. If I type cd and click the path, and after I type gl, when I click tab, essentially what it does is autofills all the commands that are available for me. And when I do that, it autofills it for me. Like I can cd and I can list all the files out there. Okay. Let's say you're in this particular folder and it lists all the files that I've seen over here, right? So you can enter, if you want to enter a particular folder over here, you can give a relative path to it. I can say cd I don't know if I have permissions to use that particular folder, but let me check. If I do that, I can enter into that particular folder. So I am in folder and nothing is there as of now. So in the cd command, there is one more thing that I missed. Probably that's a good time to explore that. There are a few options for the change directory command. If you say cd dash or hyphen, it takes you to the previous folder that you are in. For example, right now, let's say I'm in my home directory. Cd without any command just takes you to the home directory. And if I do cd dash, previously I'm in this particular folder, right? Or hyphen, like it takes me to that particular folder. And you can see that, oh, nicely prints out which folder I'm in as well. Like, so I'm currently in this particular folder right now. Similarly, if you want to go back one particular folder, it's cd dot. That takes me to the one folder up. In pwd, you can see that I'm in this particular directory. And you can use dot and dot essentially to give a relative path to where you want to navigate. If you list all the files that are available here, you can see that there is a dot and there's a dot. Dot means the parent folder and dot means the current folder. Say if I want to go into this particular folder, you can just type intro Python, or it's also equivalent to my current folder over here, which is represented by this dot, and I can type intro Python, and I'll navigate to that particular folder. You can also use dot to navigate to, but let me go to this particular folder. And if I want to get into Linux, that's a subdirectory of the parent directory. What I can do is dot and then intro Linux. So I'm in the intro Python directory over here. I'm going one step above to the parent directory and getting into intro Linux. So that's how it goes. Okay. If everyone is good, let's move on to the next few commands. Initially, right now, we have just started with Linux and also like Linux command line, and we are just navigating between the three different folders, like listing what are the files over there, and what printing out where we are. The commands that we use till now are pwd, ls, and cd. And man is a manual command, which essentially lists out what are the options that are available. Let's move forward and create some files in the folders, okay? What we can do right now is so if you go to this particular folder, intro to Linux, again, this is the path. I have a folder called, one path above, like pwd. I have a folder called SA users, and I have given all the users permissions to create folders over there and files over there. So cd into this particular folder. I'll post the exact path in the directory in the chat, and you can just post it. And we'll do the rest of the exercise for you. Give me a quick thumbs up, like if everyone has navigated to this folder or like having any difficulties navigating to this folder. So next set of exercises that we'll be doing is we'll create a folder for each user. What you can do is you can create a folder with your username, which is SA130, your username followed by the 3 digits. Mine is all SA130, all zeros. So let me make a directory. To create a directory, there is a command called make directory or mkdir. And I will do SA130000. The last 3 digits, I mean, this can be any folder name. This doesn't have to be this, but just create a file over here. And that I will also get an understanding of how many people are able to do it because I can see the folders created over there. And if I click list, now I have a directory called, yes, quite a few people have already done it. Like, oh yeah, you can also tag it with Linux. It's up to you. Someone has a question, like you can go ahead and ask. Cameron, I think you have a question. You can go ahead and ask the question. You can unmute yourself. Or you can post it on the chat as well. Okay, the next command we'll try out is a touch command. Like you can use this to create files in your and blank file. There are different ways of doing it, but if you use touch, essentially it just creates a blank file in this particular directory. So what I want you to do is navigate to your own folder that you created. In my case, I will go to this folder. And create a file called new file. That's very descriptive. Yeah, I see quite a few people have created the files. Like if you have any issues, like do let me know, but I will move ahead. Now you want to enter something in this particular file, right? There are different ways of doing it. If you are getting started, like probably the easiest editor that you can use on a command line is Nano. I typically use VI, but if you are getting started, like Nano can be really useful. And if if you want to run on your local system, like there is another editor called gedit, like, but it's not available on the cluster, that you can open, and it gives you a nice interface as a notepad and you can enter it. But I'll be using Nano for now. It's been a while since I used, hopefully. Now I will enter the first command. I can say this is the first line entered from the editor, something like that. And one good thing about Nano when you're getting started is it gives you all the few options that are available that you can use. Let's say you want to exit the browser, you can either use Control X or Command X, depending on the system that you're using or the keyboard that you have. And if I use Control X, it's prompting me, should I save the file or not? I can click yes, and that will save it. And that will save the command. If I open, there is also one more editor called VI. I opened it with VI. Like VI is less intuitive, but like I find it to be more useful for my thing. But it's a personal preference. Like you can use any of the editors that you want. For getting started, you can use Nano for now. So I saved this file, and this file has content called, this is the first line entered from the editor. There are a few different ways that you can write to these files. So there is a command called echo, which essentially echoes the command, whatever you enter after the echo command within the double quotes, to the standard output. Like in this case, if I simply type, this is a line, and enter it, it will just print out this is a line to the screen, because the standard error and standard output, like the output is set to the screen. So whatever output I have from this command is printed to the screen. I can change the standard input to a particular file using a line called this. This is a line from echo. Command, and I can just I'm using greater than symbol over here to redirect this this particular output, the output that I have from here, to a particular file. I'll just do new file.txt, and if you see, I'm using the tab command to autocomplete. I'm not typing in the complete thing. So if I do new and click tab, that auto completes for me, and that way you can be really fast when you're on your command line. When I do that and I say new line.text, if I open new new file again, so when I enter this, the standard output, like it creates a new file. The old file that is there is wiped out, and the contents are the content which I entered in the output has been a new file has been created and it's entered. There is another way of redirecting it without deleting the file. If you use greater than symbol twice, and if you enter it again, you can see that new file, and I have all the files, all the commands that I entered, all the lines that I have entered using the echo command that are saved into this particular file. Yes. Control, just use escape. Use escape. Someone has a question saying that I'm unable to exit the VI screen using the WX. use the escape, type the escape command a couple of times, and then type in :WQ. That will show up like this, and you can exit it. Another way, let me see if Joshua is saying that I'm getting permission denied for the new file. Can you let me know which folder you are in? I'll get to file permissions. Like that's a very good question. Probably it has to do with file permissions. Like if you want to ask a question, you can also unmute yourself if you are comfortable. That's all it is. So one more thing that I want to say is I created a folder for myself, and I'm the owner of that particular file, of that particular folder. If I go to SA, I'll get into file permissions in much more detail a bit later, just to give you a glimpse of how the permissions work. If I CD to SA 10003, that's fine. And if I try to create a file here, it creates a file without any complaints. But if I want to create a file somewhere else, like let's see what are the file permissions for rest of the group. So I'm going to try to create a file in this particular user's home directory. Let me see. If you type ls.la command, like it's a long format, it gives you much more information about the folders and files that you're entering than just listing out the files. So in this case, the first line shows the file permissions. And I will tell you why this is the case, but I only have read permissions to this particular folder. Let's see if I can go into that folder. I just picked this folder, which is not owned by me. This is owned by some other user. This is my username. What did I do wrong? Okay, sorry. I can go into the folder. I can list the files. But if I want to create something like this, let's see what happens. I hope this one doesn't work. Let's see. It gives me a permission denied error because I don't have permission to write in this user file name. I can only read from here. Like the R over here stands for read, and only I have the permission to read, not write. So the user had the permission to write, and anyone else, like not belonging to this group, I belong to this particular group. So I won't be able to, no one else will be able to read or write into this particular folder. Only the user can write in this folder. That's why, that's probably you're in the wrong folder. Like if you can give me the file path, like we can troubleshoot that. So that's echo command. I think I have covered the echo command, and nano is the text editor. And there is one more command called cat. Every time that you want to see a file content, you might not want to open the file, or if you are doing some processing or you want to use the file, the text content, or like any content that's available in the file in some other program, there is another, like you can do that without opening the file, like without opening it in an editor. Let me go back to my own folder again, SA13000. And if I list the files over here, it says me I have two files, but I don't want to open the file with using a VI editor and exiting and things like that. So I can just use cat command, which essentially gives you all the content of the file. I enter new file. And if I type enter, the content of this file is printed to the screen. So I can say this is the file line. If I open the new file, this is what I see. And pretty much I see the same thing in this particular folder as well. A few more things when you're using a VI editor, if you choose to use it. If you want to save the file, you have to type in WQ command. But if you don't want to save anything, you type Q and you can exit it. Sometimes it gives you an error if you make any modifications. You can type Q/ to ignore the changes and keep the file as it is. So for example, if I insert and I enter some random keys over here, I click escape and I type in Q, it gives me an error saying that because I tried to change it, I can't override it. What I can do is I can say, sorry, and that will not override the command. And I can see that my file hasn't changed. If you're planning to use UI editor, that's something that's more useful just to keep in mind, because you don't want to change the files that you're using. I'll post that in the chat. No changes. Those are the commands that you want to create the files. Like if you want to create a text file, or if you want to create folders that you want to save, those are the commands that you'll be using. Next, we'll be moving ahead to move the files within the file system that we have access to. Now I'll create a new folder called backup. And I'm going to have these 3 files in the folder, new files, second file, and so on. And I want to back up this file in the backup folder. The way I'm going to do is, you can use copy, CP, which stands for copy, new file, .txt, and backup. What this command says is, this is the command that I'm running. It stands for copy. This is the file that I want to copy. To be more explicit, you can say that a relative path of this particular file, which is the current working directory and the file name. And I want to move it to this particular directory. I can be either explicit, or you can just ignore this as well. And I want to move to a backup directory in this particular folder. If I do that and list it, like I have my file in this particular folder, and if I list the folders in backup, it'll list all the files that I have in the backup as well. And if I can do cat backup new line, new file, that prints out all the files that all the commands that I have, all the text that I have in the new folder. That's copy. Stands for copy. Source, destination. Files. Second command is move, to move the files. So if I do move, I'm clearing the screen, Control L, and I'm clicking LS. if I want to move the file like from second.txt to the backup folder, what I can do is second file.txt and backup. Make sure that you put a slash after this. Like if I just enter move second file to backup, it will rename the file as backup, and that backup file will be essentially gone. So this slash indicates that move that folder to the backup folder. Now, if I say ls backup, it says that I have two new files. Second file has been moved over here. And if I do ls in my current working directory, which is this, I don't see second file because it has been always moved. By mistake, if I have done this, like it says that I can't move it to backup because that's already a folder. Oh, sorry. No. If I move this, let's see what happens. It didn't complain, it moved. But if I click lens, oh, it actually moved. Okay. Yeah, it moved that file to that folder as well. Sorry about that. It actually moves into the folder. You don't have to be explicit, but it's better to specify the backslash. Sometimes in some commands, I have seen that it renames the file to that particular file. You have to be very cautious using the remove command. Unlike Windows, you have a command called rm, which essentially removes the command. But unlike Windows, if you remove the file is gone for good. Like there is no recycle bin that you can retrieve the file from. So be cautious about using the remove command, because once it's deleted for good. I can do the same thing here. I'll say remove rf, no, not rf, new file, and that will if I click, the file is gone. If you want to delete a folder, the way you are going to do is remove recursively all the files. You can go to the man page to see all the flags that are available for remove. And you can list that. You can say that if F means like it is forced to remove. And if you go down, there is one more flag called -R, which removes the directory and the content recursively. So like if you want to delete a directory, you want to delete the files within that directory. So this is the way to do it. But again, be very cautious when you're using remove command. The files are essentially gone for good. There is no way of retrieving it. There is a question called how can I go back from the man pages? So essentially type Q, like click escape and type :Q, and that will exit it. Escape. So now if I list it, I don't see any files in my folder. But one thing to notice, like be cautious, like because you can essentially delete your whole folders. Like there is also a wildcard entry called asterisk. I'll never run this command, but like what it does is it essentially removes everything that I have in this particular folder. There might be hidden folders like in your home directory. If I go to home, although I don't see anything here, there are some hidden files. Like if I type LA, anything that starts with a dot is a hidden file. Like -rc is the first thing that you use. Even if you think that there are no files over here, if I do this, essentially it will clear out my home space. That's something to be very cautious of. And lastly, you can create links to the files. Like these are essentially equivalent to shortcuts in Windows operating system. So let's go back. In Intro to Linux, I have a file called course material over here. I want to create a link to that particular file in my own directory, which is SA users that I created for myself. If you want to create a link to that, either you can create a hard link or soft link. Like I'll not get into that, but I can say what's the link that I want to create and what's the name of the link. I'll say course link, and I can give the complete path to that particular folder, to that particular file. So it's the source first, and so I created a link, a soft link to this particular file, this particular folder. So if I want to navigate to this particular folder, I don't need to type in the whole thing. Like if I want to navigate from here, what I can do is I can simply type course material link, and that will essentially get me to that particular folder over there. It still shows as course material link because that was created as a soft link. But if I do pwd, that's the actual, there is a link that is created from this particular folder to there, and I can pretty much access all the course content from here. This is pretty much equivalent to what you have in that particular folder. Essentially, these are the same files, but there are two different links to the same files, like that are created using the link. If I go to the same folder here, if I actually cd to this folder, you'll pretty much see the same files that are created here. See, it's the same. Okay. What else do I have here? Yeah, that's a quick intro about how to create files and move files and so on. That takes me to the next exercise that we have. I think you have already created this. Like I want to change to the folder and create a file name, a directory name called SA1300XXX. This is already done. While we are doing the exercise, I think if you haven't already done that, like create a file in this particular folder, enter the first line into the folder, like either using vi or the echo commands that I used, and copy these files to the new file, and essentially the exercises that I essentially did. And copy this to the new file. You don't need to make a new folder, like just use the same folder. Like this exercise is already conducted, like so ignore the first step. This is already taken care of. Let me do that. Now in that particular folder, like create a file called new file or test file or something like that, and enter this particular line, and copy that to another folder and create a second line into it. I probably will take 10 minutes for this as well. Like, if you are done with it, like, just give me a thumbs up so that I know that we can proceed. Can you see the functions again? Yes, of course. So these are the functions to create the files. I'll type it in the chat so that it's all in one place. So essentially, touch command is to create a this is to create files. VCP copy or new files. Now you can also use remove command, but be cautious when you're deleting a file. It's 11:05 right now. Like we will have until 11:15, or depending on how many people have completed the exercise, 11:15 or 11:10 before we move ahead. If you have any questions, feel free to unmute yourself and ask the question, or you can post it in the chat as well. How do I open the file after I type something? You can use an editor to open it. Like, let's say if I create a file called, say, file.txt. Okay, first I have to touch the file. So I created a file called testfile.txt. If I cat testfile.cst, this is a new file. And if I want to open it, there are quite a few editors, like Nano is one, VI is one, and Emacs is one. I'm sure there are several other editors as well. If you want to open it, you can use Nano, followed by the file name that you want to use. And that will open the file. And you can enter anything that you want after this as well. It's like a text editor. And if you are not on Frontend cluster, and if you are using your own terminal on Ubuntu, let's say, you also have gedit to open the files, but I don't think you can use it on the cluster. At least I never used it. Then how do I move the file to the next file? So the way you can do it is you can just copy that to the next file. Like, sorry. If I do testfile.pp to new file.txt, that will create two files in my folder. And if I open VI is my go-to, like I'll probably use VI. If I open the file, like you can see that it's created a new file. If you want to There are other ways to do it. Like if you want to move take the input from that particular command and move it to a second file, there is something called piping that I will be getting into a little after. And there are ways to pipe your commands to get into different folders. Justin, does that answer your question? If you want to move the file, it's useful. To get out of VI, type the escape command and type :Q. Type in escape a couple of times. If you're stuck in something else, that will get you out of it. And one thing about QI is Control-C doesn't work and it goes to some other state. So that's something need to be wary of. Unless you get comfortable with, I would suggest using Nano for now, because it'll list out all the commands that you can use to get out. So probably getting started with Nano will be easier. See. Yeah, to get out of Nano, it's Control-X. Okay, it's almost 11:15 right now, so let's move ahead with the rest of the slides. I have quite a few to cover. So coming to, you have created the files, and there are some files that you downloaded from somewhere. How do you get to examine your files. Like you can open it with an editor and examine it, but like the files can be huge sometimes. Like they can have 10,000 lines or like a million lines in it. And if you are using an editor, like it's not always possible to see to get the information that you want just by looking at it. So there are certain commands that we can use to explore the file content. I'll start with more and less. These commands are equivalent, in terms of what they can do, but the functionality is slightly different. So if I go to graph tutorial, if I try to before we do that, I want you to copy the files that are there in this particular folder to your own files and tar it wd. Post the command in the chat. You want to copy tar file that you see here into your own directories, and we can play with a couple of things that you can do with that. We can explore the files that are there in the course material. I'm assuming you're already familiar with this command. So what I want you to do is, I want you to copy the files that you have in this particular folder, in this particular file to your local folder. It will look something like this. Last 3 digits are your username or the folder that you created. It might not be this. It might be it's usually your username or the file that you created in SA account. And mine is SA13000. And I'm copying it over there. And I CD to that particular command. CD to that particular folder. I'm changing my directory there. I can extract once you are here, you can extract it using the tar command to get the contents of the file. If everyone has done this, let me know. We can then proceed. Or I'll just give 1-2 minutes for everyone to do this, and then we'll explore less of the commands based on the course material that I have here. Oh yeah. So you navigate to this particular folder. Let's do one thing. Create a variable called Linux directory or something like that. The name is not important, but it will save us a lot of I'll post it in the chat. And I can use this variable to essentially Getting to this a bit later, but all right. Yeah, there is a file called that. Now you can copy, make this directory, call this, and then copy this folder to to this is the command that I'm using for mine, but the last username will change depending on the folder that you created, or you can create this folder as well. So essentially what I'm doing is I created a file environment variable called global project workshop intro to Linux, where that's where all the Linux for course content is. From there, I'm copying, I'm using this as an alias to refer to that particular line. And my actual files are in global project workshop 2022 SA users and followed by the username. So I'm copying it from the source directory to the target directory, and then I'm seeding it to the target directory. And if you click ls, once you do that, you should be able to see a file called this in here, and you can untar it, like unzip it using tar xvfz course material. And that I have already untarred it, so like I will not repeat the steps, but like you can just untar it like that. So once you have done that, like I'll quickly go the step. There are 4 commands that I wanted to discuss over here. One is more, less, head and tail. If I go to a folder called, let's say, first I'll go to shell scripting folder. This is just for demo. Like I have an exercise after this, like that you can work on. So if I want to view the folders with VI, I can just type in, or I'll do cat 01, and that prints out the content of the files onto the screen, or you can view that to the screen. But if I do the same thing with a larger file, this is a small file and that's okay. If I do it with a larger file, it gets quite annoying. Like these are some files that I downloaded from online, which are pretty large. I think this is related to informatics. So it spits out a lot of things and it goes on forever until it exits. So you can't essentially see what's going on. So the way to actually explore these files is I typed Control C to exit out of that, Control C or Command C, to send a signal to about the cat operation that I have done. What I can do is I can type more and followed by the file name. This is a nice utility where you can it gives you the content page by page. At least you can read through it. Like initially I typed more and some content is given to me. I can either type enter to move line by line, or I can type space on my keyboard to go one page down. So that way, like you will be able to, if you want to see the content of the file, like you just want to see, let's say you want to use the data for something else. And if you want to explore what this is, you want to, you have a Python script that reads this file and you are writing a Python script on what to explore the test or do some, extract some data from this. What you can do is like you can get the format, you can type more and the file that you want to see, then that will give you a general sense of what the file format looks like. If it's a typical particular file formatted way, and that gives you an option to explore it. If you want to exit out of this, same thing, like you can type colon Q, and that will exit out of the file. Same thing with less, you can do the same thing. It's a very similar command, but the keys and everything are slightly different. Same thing, you can use enter or space, and if you quit, it'll exit from the session. And also sometimes you want to explore the files at the top to know the headers for the files, like what are the headers in my files, or like I want to know what's the last entry in my file. I don't care like what are all the things. Like this is especially useful if you're logging some data and you are not concerned about the whole file that is over there. You just want to know like a couple of entries, last 10 entries or last 20 entries. A good example of this is history. In my home directory, I have a file called --bash history, and it gives me it saves a bunch of commands. Like essentially, these are all the commands that I used until now. Let's say if I don't have the history command, I just wanted to know like what are the last 10 commands I used. Then you can say that you can use the tail command to explore this particular option. I can say tail, and let's do 20 because that can be printed to my screen. -, and I type in history. It doesn't print out the whole thing that's available. It just gives me what is available in the last 20 lines of the file. If I do VI and do this is not a huge file. Probably it has like 200 or 300 lines, so it's not an issue over here. So it gives me all the lines that are available. But I'm only interested in 9. I don't have to navigate through the whole file, and I just need the last few entries that are there. Same thing with the header as well. If I do head, and so what I'm saying is give me 10 new lines, -n says that how many lines do I want. And if I type in -bash, this will give you the first 10 entries that I entered. These are the first entries that I entered when I just logged into my system, or first 10 entries that is saved in my system right now. This can really be useful if I want to see what this file looks like. If I can type more, sorry, not more, head. If I type head without any flags, what it essentially does is like, I think it gives me 5 first lines in the file. If I can see, I think, or 5 or 10. I'm not sure about the number. Like, I think it's 10. It gives me first 10 lines of the number, of that particular header file. I can be more explicit and say that I need 20, not 10. Let's see, 20. And that gives me the first 20 lines that are there. Same thing with the tail. I can say tail, and I'll do 10. And that gives me the last 10 lines of the file. I'll take a short pause, and like if you have any questions and if you want to explore the files over there, like you're free to do that. Like I'll give 2 minutes. I have an exercise on this in a few minutes, so like we can do that at that time as well. Okay, yeah, there is a question. Okay, if you don't have any questions, let's move ahead with further slides. There are certain other commands that you can use to explore the file content. Like right now, I just used more and head and tail just to explore the first few lines, or like just to see how the file format looks like. But let's say if you want to search for a keyword, like if you want to search for a particular content that has a particular key in it, we can do that as well. Let's say I downloaded this file from an open source repository. This is a FASTQ file. And if I just type head in N1, that just gives me a general sense of what files are there. And not for any real reason. Let's say I want to explore this file where there is a certain pattern that I'm looking for in this FASTQ file. Let's say, let me copy this particular file function, and I want to search this file for this particular key. I copied it by right click, and if I do grep, we have the grep command to essentially search for the content in the file. Like if I have grep, that's a pattern that I entered. And if I wanted to search it in here, and if I do that, like it gives me all the lines that essentially contains this pattern. Like everywhere it matches this pattern, like it's showing me where it's matched, and all the lines with the matched pattern will be filtered to scale. And you can use this in output, like if you are to some other, you can pipe it to some other command to explore how many lines you have with this particular pattern or something like that. So essentially grep command is searching for lines with a particular, for searching for files or the input stream for a particular format that you receive over here. Grep has a lot of options. There is for any, this stands for any Linux command. Like you can't essentially know all the commands that are, all the flags that are available for each command. Let's say if I want to output all the files that doesn't contain this pattern, like it's a negative of this pattern, you can do that as well. The way to do it is, right now, let's say I don't remember what flag to use. I can use the man command to explore the flag, all the flags. If I come down, I should see a -v flag somewhere, which says that invert the matches. So like it prints out all the lines which doesn't have this pattern in it. So how the grep command works is it navigates through each of these files and essentially matches the pattern for any matches for this string pattern in the line, and it prints out any line that matches it. For the negative, if I want to print out all the lines that doesn't match, I can do -v, the same pattern. It's always a good idea to put single quotes across a string, but you actually don't need it, strictly speaking, in this particular. So it prints out a lot more commands because a lot more output, a lot more lines, because the lines without this operation are much more than this one, the ones with the lines. And second thing is, I just wanted to know how many lines are there in this particular file. And I can do that using WC. If I go to the man pages again, you can see that it prints, it says how many new lines are there, how many words are there, and how many byte counts for each file that is there. So that gives you a quick overview of how big is the file. If I say one, it gives me, it has 18,000 lines and it has 41,000 words, and this is the amount of space in bytes. Let's say if I only need the number of lines, there is a flag for that. And it says that these are the number of lines in this particular folder, in this particular file. Let's say if let's say if you want to not look for a particular string, but like there are some regular expressions that are available for grep commands that you can use to match the patterns. Let's say if I want to print all the files that are available here, which is of .txt format, like which has an extension of .txt, I can use this using wildcards. I can say ls, which is the list command, and I can say asterisk, which essentially means the wildcard. It can be anything. It can txt, and that gives me the list of files that are available here. Again, like I'll post all the slides with all the commands later, like so you have access to all the course material, including the slides. So that gives asterisk is essentially any character must appear before this particular pattern 0 or more times. In this case, if you have a .text file or any string before that, it will print all the files that contain .text.dst. And there is another file called dot, which essentially looks for, if I put dot over there, it will print out any file that has one single character can be replaced from here. It can be any character, like it can be alphanumerical or it can be special characters as well. Okay, this is not dot. I think I have to escape that. Okay, this doesn't work for list commands, but like let's come back to that particular command a little later. But there are several other commands that you can use so if I do name.txt, so if I do this, like it says, if I put a question mark over there, it replaces one particular character that needs to be printed instead of this, and that list, because there is only one particular file which has with this particular pattern, it prints out that particular command. Regular expressions is a bit of an advanced thing for introduction to Linux, but note that like there are regular expressions available, and you can use wildcards and regular expressions to search for the content of the file or search for the file directories and so on and so forth. And lastly, we also have pipe command. So what we can have is like output from one command can be used as an input for some other command, like the standard output that we get from, let's say, cat command. In this case, I wanted to, if I use cat command, that essentially prints out all the files that are there, all the content of the file. I can use pipe command, which is an OR symbol just above your enter key on the keyboard, and you have to probably press shift and the key just above it, like it, and when you enter it, and you can say wc.l. So what this does is it prints out all the file content to this particular to the standard output, which is the screen. But instead of I'm asking, instead of printing it to the screen, take this as an input stream for the next command that I do. And you can have multiple commands with that particular output. Let's say if I want to do this, if I print this, it will say me that it has these many files, because this many lines, because this is the file that has been transferred. And I'm doing word count on this with number of lines. So it gives me all the number of lines that are contained in that. Let's say if you're searching for a particular pattern that we've searched before, this one, if I want to know how many lines are there with this particular pattern, I can do the same thing. I can say grep you can have multiple pipes. So like the output from this, which is output, which just outputs the output the content of this file to the standard output, which is the screen, but I'm piping it to a different command, which is the grep. And this grep command looks for this particular pattern in the command, in the content of this particular file, which is kind of redirected to this command. And again, you can redirect it to this output, to WC, which counts the number of lines. And when I type that, it gives me 1112 lines, which is essentially the number of lines that I have with this particular pattern unit. So with that, I will post the commands that I'm using, here. So commands grep WC and what else? Yeah. I will quickly go over a quick exercise before we go to the break. Like you can probably do it during the break itself, or after we come back from the break. So in the next set of files, navigate to the files that you copied and go into this particular folder. For my case, this is in here. If someone, you need to replace this particular path with your username, and you can find the folders in there. And what I want to do is essentially repeat the steps that I said over here. You can count the number of lines in this particular file, essentially. Either you can copy it from the folder that you have. If you already copied everything, just go to this folder and count the number of files that you have in this particular file that you have. There is an optional exercise as well. You can find the number of lines with the genomic sequence, which starts with the content ACTG. Like if you look at the file content over here, there are a couple of lines just that contains ACTG. And if you want to list out only the number of lines that only has these particular lines, you can do that as well. Okay. So after you log in, copy this file to your own folder. The way you do it is, these are the commands that you need to run to copy and untar the files in your home directory. It's 11:46 right now. We'll take a short 15-minute breaks after you can work on the exercise, and if you have any questions, feel free to ask. I'll be here. And if you have any questions like regarding the exercises that are covered until this point, or how to do the exercises, please let me know. Hi, Jamie. I think we can stop the recording. We have 1 more minute. In the meanwhile, we'll just start in a minute. I'll just quickly show, go over the tutorial. I just asked to get the number of lines that are there in this particular file, which we have already done. Let me see. So just to count the files, it's pretty straightforward. It's wc-l, and that's it. And there are a few different ways of doing it. It's cat, and I can pipe this to another command, the output from this command, which is the output, is taken as the input stream for this command. And that's called piping. You pipe from one command to the other, and you can have multiple pipes. And that gives me the number of lines. And the last exercise I mentioned is, I didn't go over this, but this is, I just wanted to find out the number of lines that contains the genome sequence, anything that only contains ACTG. The way you can do that is, it's a repeated pattern of either A or C or G or T, and it repeats throughout the line. The way we can do this is through this. I can say, I'll use the pipe again. I can cat all the output, and I'm streaming it to grep ACTG. If I type this thing a bunch of times, and again, if I pipe that to wc.l, that gives me all the lines that are having this genome sequence. Essentially, what this pattern essentially does is, let me store first 100 lines of this FastView file. A new file dot first. This is just for demonstration. And if I do, and it has 100 lines of this. If I do new file grep, and a particular pattern. Let's say I want to do search for this pattern. I can search it, and that will give all the lines that has this pattern, right? But I want to search anything that starts with like ACTG and follows, like the next line is ACTG and next character is ACTG. So what I can do is, under the square brackets, I can say ACTG. I'm repeating this a couple of times, like 8 times. If I repeat it 8 times, I know that if any sequence, any line has that particular line, I'm assuming that that's a genome sequence. So what this essentially does is it replaces like the first word, if it contains any of these lines, A, C, T, G, or any of this, the second line contains A, C, T, G. And if I do that, if I print it out, you can see that all the patterns that are matched with this. So because I'm taking a set of 8s, like it's matching for those patterns set of 8s, and everything that has this genome sequence is essentially outputted to this. And I can count the number of lines using essentially that. Because I have 100 lines, 1/4 of it is the genome sequence if you look through the file. So that's why I have 25 lines of it. That's a quick on the exercise. Now we will move ahead and like to copy and to move the files between the systems. Like you have your files on your local machine, but you want to copy these files onto the cluster because you want to analyze them using the cluster, or you want to download some files from online, like you have from GitHub pages, or there is a source code that you want to install in your home directories and you want to use that application. There are certain ways of downloading a few things. First, I'll go through a couple of things like where we can download from online, like you have a tar file somewhere, or you have a GitHub page, and if you want to download it, you can run the following commands. In the grep tutorial itself, in this particular file, I have the download commands. I'll just print it out. Just I put this for the ease of it. Let's say if I want to download something from here, this is the link. If I and this is a FTP link that I got online. And if I want to download it, like I can say wget followed by the web link, and that will essentially download the files to your home directory. I have already done this, but like you can see that this particular file has been downloaded to my system, and I can see that it's saved to this particular file. And if I list this file with the long format, I can say that it's downloaded around October 17th, which is now. The file has been changed around October 17th, and the timestamp is 12/6, which is the current time at this moment. Let's say there is one more package that I want to download from GitHub. This is Net 5000. There's no particular reason for downloading this, but I have recently used this, so I thought. And if you go to the GitHub page, like if you go to the releases over here, you will have the source tar files over here, and you can download it. You can either copy this link, and you can say wget and extension to the tar file. Provided that you have access to this particular file, it will be downloaded to your system. So if I do, this is the file name, probably ls. You can see that there is a tar file called next 5000 given by this. If you are using GitHub, like you can also go use git clone, and the code is over here. Just you can copy this line. That gives you the master directory in the GitHub pages. And if you do git clone, that downloads the actual files in your system. So I think it downloads as a tar file, and I have a new folder called net 5000. That's how you can download. These are a couple of options. Like there are other files, other commands as well called curl and things like that, where you can FTP and things like that, where you can download the files from online. But you can use Git or wget or git clone more often to install the files that you want to use. And followed by that, if you are installing it as a tar, downloading it as a tar file, you can untar it using tar xvfz and the tar command up here, and that essentially untars it for you. Like it essentially, because it's the same file name, it's writing it to the same folder. That's not what we wanted, but that's creating a new folder, and you can see all the file content in that particular folder. And finally, you want to, there's a question. Okay, so this is the slides, to download a file from online or from a GitHub, you have two particular commands. One is wget, and wget followed by the URL link. Like in this case, if I do wget followed by the URL link that is provided to me, that will download the files to my home directory. Not home directory, to the current working directory. Same way, you can use git clone over here to essentially download the files from GitHub as well. This is the GitHub link for this page. And if I do git clone followed by the GitHub page link, which is provided over here, usually if you go to the code over here, usually there is a link provided that you can copy, and that will download the master repo of that particular repository, essentially. Does that answer the question? And then I used the tar command. So when I downloaded a tar file using wget, what I downloaded is this particular file. I did ls to essentially list the commands. And to untar it, it's a tar file, so you have to unzip it essentially. So for that, tar xvfz, these are certain flags that are defined to unzip the file. X says that I want to uncompress the file that is followed by this. And these are all files. And last one specifies the file format. And V stands for verbose, which is essentially it. If I don't have the V command, it doesn't say anything, but it does something in the background. But if I have V flag over there, it tells me as the process goes through, these are the files that are being untarred and so on and so forth. Same thing with any command, you can't be exhaustive of all the flags that you know to know about a particular command. So you can use all the man pages to essentially look through all the flags and use them accordingly. And finally, you have some files on your local system that you want to do some analysis on. You have some data, or you have input files that you stored for your simulation. And let's say you have an Abacus or some MATLAB scripts that you have in your local computer, and you want to upload it to the cluster. There are a few ways of doing it. If you want to do on the command line, you have to use something called scp command. I'm going to use MobaXterm for it, because the reason I'm using MobaXterm for this is it has a nice interface to essentially upload and download files directly. Where's my MobaXterm? You can do this with your local machine as well. This is not a particularly pertain to Mobile Extra. Let me create a file called local file. So I can say this is on my local machine. I'm creating a file called a local file. I'm doing echo. This is a local file. File equals on my laptop. I'm doing local file. If I print the, not sure if it's visible. If I print the output of this, this file is on my laptop, and I want to upload it to my home directory. The way I'm going to do it is using this particular command. I'll post this. So you do, there's a command called SCP, which stands for secure copy. And -r flag says that if you are copying the files recursively, let's say if you want to upload a folder, you have to use the -r file. And first you need to specify the source of the path. In this example, I'm using a file name called my file. And then you have to specify the server where you want to upload it to, followed by the destination path. We will go over this on the command line. I see SCP. Because I'm uploading a single file, I don't need to use the -r file, which stands for recursive. But just for completeness, I'm still using it. This is the file on my local machine. And then I'm uploading it to my user account on in my home directory. The way I'm going to do it is, I say my username @ login.cac.queensu.ca. This is the same address that you use to log into the cluster, and colon, followed by the path that I want to upload it to. A tilde is a shortcut for the home directory. So I'm just uploading it to my home directory. When I do that, it will prompt me to enter my password, same as when you log in. Hopefully I didn't forget my password. I'm entering it again because so you can see that after entering the password, it says that the local, it shows you the progress of it. Because it's a very small file, it took less than a second to do it. But if you are uploading a gigabyte of file, like this would take some time because it's going over the internet to essentially load it. So when I log in into the cluster, take me a bit of time. Okay. So once I log in, I can see that ls, and I can see that the file has been uploaded to my system. Like if I do cat local this file, it says that this file was on my laptop. So essentially, you can use using the scp command, which is this particular line. I gave the path to my source file, which is this one, like local file.txt in the current file directory, and I uploaded it to the frontnet cluster, the login node, to my home directory using my username over here. Instead of home directory, you can specify the directory that you want to upload as well. You can do something like this. I'm not going to do, this won't work on the command line. So sometimes what happens is to upload the files, like you are already in the cluster, and I have noticed that like sometimes it can be confusing, and like you're trying to upload the file from your local system. Some other file, with the directory to one point of contention, confusion is like if you enter this on the cluster itself, you're on the login nodes, like you are on the frontnet cluster, and if you're trying to upload the file from your local machine to this, it's taking some time to throw the error, but it won't work. The reason for that is this file is on your system, and the frontend cluster doesn't know what files are in your system. So you have to do this from your local machine into the cluster. Like you can't do it the other way. The reason for that is from frontnet cluster, I can't reach your local machine because it doesn't have it. There is no web address for that, your local machine. So you have to do it the other way. You have to log in, they go to your local shell and then upload the files from there. In addition, if you are using MobiXterm, or there are certain GUI interfaces that are available, so there is a SFTP server that starts next to the command line, and actually you can upload files from here. Let's say, let me remove the file again, local file. And let's say I want to upload the file. So on the on the left-hand side over here, you can see that there are certain files that are shown here. So these are all the files on your home directory on the cluster. And if you want to upload a file from your local machine, there are nice little buttons over here. Either you can download the file to your local machine, or you can upload it to the cluster. You can click, and then now I am in my, it gives a nice interface to my Windows File Explorer, and I can say, okay, copy this file to this. And it would take some time. It won't complete immediately, but you can upload the files using this method as well. That's one advantage of MobiXterm when compared to using the command line. And in addition, we also have Globus. I won't be covering this, but if you have large data sets, if you're doing SFTP or SCP interfaces to upload the files, you might lose the connection in between, and the integrity of the file might be lost. So in order to ensure that, there is an interface called Globus, which is used to transfer large data sets. And there is a web link over here. I'll be uploading the files to the course material as well. So like you can find the link for this over here. This is a quick exercise that you can try to do after the session. Like if you have any questions, you can always reach out to us. I will post my email address page. You can reach me. But you just create a file on your local machine and upload it to the computer. The same exercise that I did over here. There are a few things that I want to cover, at least these two parts. So I will be just moving a bit ahead. So the next thing I wanted to cover is the redirecting of input and output from the application that you're running to a file. What I mean by that is the output, like any command that you have seen, like let's say if you do cat and the file name, that's printing out output from the file to the standard output, which is your screen. But let's say I don't want it to go to the screen. I want it to go to the file. We have covered this. We can use the less than symbol to redirect that output to a particular file. Same way, if you want something to be read from a file to your application, you can use the less than symbol, this arrow symbol, to essentially redirect it to your application. In addition to that, each application has access to two particular files called standard out and standard error. These are essentially files or devices where that streams your output or error messages to a particular file or device. So by default, anything that you see by default, this output is, when you are working on the command line, this output is streamed to the screen. So that's why when you do cat or any other commands over here, it's printing to the screen. To explore this in a bit detail, I have a C program. You don't need to know what that program does, but there is a folder called redirect input output. If you go to this particular folder, that's the path I have this on. And if I say, I have already compiled a C program that's called calculate pi, which essentially by some means calculates the value of pi using some mathematical approximations. How the program works is not that important for this, but what I wanted to show is this is a C program, and what it does is based on the arguments that I give, either it takes an integer value or it doesn't take an integer value and streams the output to standard error or standard output, standard out. And we will, and if I run this program as it is, if I say calculate pi and run it, so it's saying that no, I have streamed standard error and standard output to the screen by default, and it's printing no arguments have been entered to, and the default value is considered to this. This is some value it's taking and calculating the value of pi, which is giving out to be this one, 3.14, which is a close approximation. But let's see what happens when I do this. If I go to the program and if you look for this particular line, and if I grep it, it's compiled from this. So this is coming from a printf statement that is printing to a standard output, a standard error file. And let's say where this is command is coming from. Nice. So this is the output that's going to the standard out, and it's calculating some value of pi and essentially printing it out. When I run this particular executable, which I compiled from the source code, it's printing everything to the screen. But I don't want everything to be printed to the screen. I want to save this for later use. I want to do some processing. This value is not that useful, but let's say I want to use it to standard out and standard error to a particular stream. What I can do is I can say calculate pi and redirect one. If I type 1 and greater than symbol, I'm redirecting one stand is an alias for standard out, and I'm redirecting it to out.text. Similarly, I can say to error.txt. And if I run that, nothing is printed to the screen. But what I did is I redirected a standard out to out.text, and I redirected the standard in error to error.text. Let me use cat command to print out what that says. So I have whatever is printed on standard out is printed to the screen. The value of pi is 3.416. And if I print out what's there in error.txt, so the standard error message is printed out, no arguments were entered, and the default value is so. So this way you can redirect your outputs to different file streams. This is really useful when you are writing your scripts and running your applications. You don't want it to print it to the screen because that's essentially lost. You want to save it to a particular file, you can use these notations to essentially stream the outputs to somewhere. That's about redirecting. And one more time, topic that I want to, this becomes really important when you are working on a shared system like frontend cluster, is the file permissions. Because there are several users, like you have seen, there are several folders that are created in the same directory, and you don't want other people to access your files, right? And file permissions gives you a way on setting who can access the files and who can't. Let me type the ls command again. So I'm in project working directory. I go to the SA users file that is created for everyone. So I'll post it over here. You can cd into this. And I see a bunch of files. Slow. So I see a bunch of files. You can see that the first column over here shows you the file permissions, and the second column shows how many links are there. This is currently not that important right now. But the third column shows who is the owner of this file. Let's say if you are looking at this course material tar.tz, he's the owner of this file. Like this file belongs to 164. Probably this user copied it from the course material to this particular directory. So the ownership has been set to this particular user. And each file has a user ownership and a group ownership. All the users in SA13000 belongs to a Unix group called SG130.000. That's how the accounts were created. This shares the group ownership. It doesn't need to be this group owner. It could be something else. It could be Rakesh.art. If that's a group, you can set it to different group owners. And then these particular, there is a 10-character line in the first command, in the first column, which essentially sets the file permissions. So the first character essentially says whether it's a directory or a file, followed by 3 characters, which essentially says what the permission is for the user. This particular user can essentially read, write, and execute. If it's an executable file, that user can execute the file, essentially. But when it comes to the group, anyone else in the group, like let's say 2A10129 is part of this group, but he can only read this file, but can't write anything to it, because I want to share my files with my group members, but I don't want anyone to change it. So that's why you can read the files, you can access it, you can read it and things like that, but you are not allowed to do anything with those files. You can just read it. It's essentially read only or execute only. file permissions. And the last 3 digits over here is for the others, which essentially means that you have 3 different hierarchies. One is the user, which is you, who owns the file. Then it's the group, and you can set read, write, or execute permissions to that. And then everyone else in the on who can access the machine. Let's say there is one more group called SGA14, but they're not part of this group. But if you set permissions to read, essentially they can read this file, provided they can have access to all the parent directories. This is one of the important distinction. Like, in order to read any of the files in here, they should have the permission to read all the directories over here, including global, projects, workshop, and essay. So it's hierarchical in nature, in the sense like all the top directories should be accessible to access the subdirectories. Essentially, if you just change the file permission of one of these folders, that doesn't necessarily give access to everyone else in the system. That's a quick overview of what the file permissions are. Just to refresh what I've just said, like the file permissions are denoted if you type ls./long format, which is ls.long format. It prints out a screen like this, which essentially says all the file permissions. And it's a 10-character string. The first character says whether it's a directory. If it's a file, it's simply a dash. You can see that in this case where the course material, it's simply indicated by a dash, essentially saying it's a file. And followed by 3 characters, which specify the read, write, and execute permissions. Execute is for files that are can run on the machine. Like if you have an application, let's say Python, or some program that I had, like Calculate Pi, that's an executable. In order for the executable to run, it has to need the execute permission, which is denoted by X, followed by the group permissions, followed by the others permission, everyone else on the system. For either the group members or others to access this particular folder, they need to access everything on top of it. And provided you have enough you have the ownership of those files, there are certain commands which you can change the permissions for it, which is chmod. Ch ownership can be used by a user, but there are some restrictions because it depends on whom you can transfer it to and things like that. Ch own is actually to change the ownership of the file. I'll quickly give you a demo of how to change the user permissions. Let's say like navigate to this particular folder, like SSH into this particular folder. And now if you try to access this particular file, let's say it doesn't allow you to. Let me see. Let's see. Okay, I'll try to write a file in that particular folder. See what happens. It says permission denied because I don't have the permission to write to this. But if, let's say, I say there is no files in there. I'm randomly picking a user. Sorry about that. So I can essentially look for what files are there because I belong to the same group and I have the read permission to it. But if I run the same command, some file, I get file permission error. You can try it from your own account. You can use my account, which is SA13000. and I'll change the file permissions to it. If I log in as some other user, and the way I change it is I'm changing the group permissions specify, which is this. I'm giving a write permission to I want to give a write permission to the user. The way I can do it is I can say chmod, G stands for group, U stands for user, and O stands for others. So I can specify a particular hierarchy of users. Like, let's say I can say, if I want to give write permission to everyone, I can say user group others, but I don't want to do that. I just want to give the write permissions to the user. And when I do that, and when I do SA13000, and now if you try to access my files, you should be able to access it. Like, because I have, if you create it, like if you want to write a file to my folder, like you can actually write it right now. That's the file permissions issues over here. You don't want to give it to other group members of yours if it's your own directories, but sometimes you are sharing some resources with them, and that's how you want to do it. I'll revert that. Okay. So same thing with group ownership as well. I can change the ownership of this file to someone else. I can create a make directory. I can 13000, and if I say Sean, I think I won't be able to do it because I need root permissions. A typical user won't be able to do it. But let's say I want to change the permission to 101. It says that I can't change the ownership of this, but because I don't have the permission from that user to change it, only system admins can do it. But know that like there exists a command if you're using on your local machine, you can actually chown the file permission to a different user. Or I can say groups. Yeah. That's mostly about the file permissions. We have, I created a file called example.01. Like, try to access this file and see why you can't access this particular file right now. If you have any questions, let me know. Let me see if I actually set the permissions right. Yeah, you can see that if you try to access this particular path by any chance, I'll post it in the chat. It won't show up. You won't be able to access it because I didn't give the read permissions to any of you, any of the group members. So that's essentially no one can access it except me. In Linux, like you have something called environment variables that are available to that can be used by the system to get a few things. Like 3 variables that are really useful is path, LD library path, and library paths. Path variable specifies the path to all the executables on the system. If I want to print out all the environment variables that are available, I can use this particular command called env. It will be a long list. So that essentially says all the system variables that are set or the user variables that are set up. In this case, in this particular thing, there is a variable called path. And if you want to access it, echo command is very useful in seeing what each environment variable is set to. So if I do path, I can see that all these folders, all these things are set to bin folders at different paths. Essentially, when I look for any executable, let's say Python, and if I type enter, what it will do is it will search for all the files that are in each of these directories, and it will try to find the Python, and Linux will tell you, okay, this goes in a sorted order. Like first it will check for all the libraries, all the executables available in here, followed by this line, and so on and so forth, and looks for the Python executable, and it gives you. There is another command called which, followed by the executable, that can show you where the executable is located. Essentially, it's searching for all the paths, and the Python I have is coming from this particular path. And I believe it will be somewhere in here. I can't find it, but it will be there. If you search for it, oh yeah, somewhere over there. Yeah. This is a folder that's available, and that's where it's coming from. That's where the path variable is useful for. And in addition, you have library paths and libraries. These are some, when you're creating your executable or when you're compiling your program, or when you're running your program, these are the paths that your program looks for to specify and look for a specific library files that you can use in your application. If that doesn't make sense to you, like, don't worry about that. Like, if you're compiling your codes and doing things on Linux, like, you'll get used to it. Just be aware that these environment variables exist, and you might need to tinker with them when you're compiling your codes. And along with system variables, you also can define your own variables as well. The way you do it is, see, I have this long file name, a directory that goes to my course material. I don't want to type it every time that I do. So I want to create a new variable called material directory, and I can say that I'm clearing the screen, and I can type in that, and I type enter, and if I do echo, in order to get the value of the environment variable, you have to put in order to dereference a variable, you need to put a $sign, and if I do mat there, okay, and that gives you the what string is set in this particular environment variable. Every time I want to navigate to that in this particular session, I don't have to type the whole thing. I can just say list, and that gives me the list of files that are contained here. I can cd to that particular folder as well. That becomes very handy when you're writing the scripts as well. You can have environment variables in your scripts, and you can use them to navigate or just variables in your file that you can use, similar to any programming languages. Think of it as these are the variables for shell scripting or command line. And what else is there? There is one more exercise on exploring the environment variables. I'll just quickly run through it. So right now, if I print echo path, it shows a different a set of bin paths that are set on the system. But on the Frontnet cluster, when you're using a HPC cluster, we have a command called module load. This is not important for Linux, but when you're using the cluster, this really becomes important. I want to use a different module. And when I set this module load, what it essentially does is like what it essentially does is like it sets the bunch of environment variables and it changes it. One of the variable is path. If I type in echo path again, you can see that the path of it changes. Initially, it was software 2020, like CMF soft 2020 and a long list of it. Now it changed to 2020 because that's where it's trying to look at the executable files. So in a HPC system, there are a lot of pre-compiled software that are installed in the system, but not everything is available. So using the module load command, like essentially you're setting the paths to access different executables that are installed on the system. That's one of the things with environment variables. Like essentially, it's changing the environment for you using environment variables to access different executables. Essentially, until now, we are very much at the end of the session. Like I'll quickly go over shell scripting. Until now, like we are only dealing with entering the commands on the command line. This can be useful when you're running a short analysis and things like that, but or if you are quickly looking at your files and things like that. But like if you're actually doing shell scripting, like if you're using the shell more often for your research work or reproducible work, you can store these commands in a particular file and use those files repeatedly. That's what shell scripting comes from. Shell scripting is nothing but a set of commands stored in a file, and that can be reused. This is really useful when for the reproducibility of your work and establishing your workflows, essentially. Similar to any programming language, scripting is not a programming language, but like similar to a programming language like C or anything, it has some additional functionalities. Not that you can't use it on a command line. It has if-else statements, for loops, while loops that you can use to process the data or the files that you're looking at. I will give a quick intro to shell scripting. We will not go in depth on this, but note that like shell scripting is nothing but a bunch of commands that are thrown together, and it's little more than that, but like it's a set of commands that can be reused, and there is no more functionality is available over there, or it's more easy to use in that sense. If I go to shell script, let's look at the first script that is over here. Let me use Nano. So every shell script starts with this particular line. This is called a shebang, and followed by, it starts with the shebang command, followed by the shell that you want to use. In the initial slides, I mentioned that there are various shells: born shell, born again shell, and C shell, and so on and so forth. In most GNU-based Linux systems, you have a bash shell, and that is probably the default shell. When we are running all the things on the command line, essentially we are running it on the shell, on a bash shell. You have to specify on which shell you want to run, and followed by the commands that you want to run. If I want to run this particular shell, I have to make it shell script. I have to make it an executable. The way I do it is I'm making it an executable for myself. And I'm giving the path to the shell script, essentially, like dot essentially says the current folder, and the relative path from the current folder is the file name. When I run it, it prints hello world to the file, into the system. So that's essentially, we have an echo command, and that's printing out to the cluster. Similarly, you can pass arguments to that. Like, let me see what the second. you can declare variables in the shell script as well. The thing that I was mentioning before, I said I declared a name called Rakesh, and I dereferenced the environment variable. These are user-defined environment variables, and that's echoed to the cluster, the system. I can repeat the same thing. And it says, it just replaces $name with what it's set to. And thirdly, you can also pass arguments to the shell script. So anything that, let's look at this one more carefully. So in this case, I'm just doing a bunch of echo commands clubbed together, and it has I'm passing some arguments to this particular file. Let's see what happens. I do 03. So when I do pass these arguments, and if I look at the file again, there are particular variables that are set as environment variables when you pass it to a shell script. $1 essentially specifies the argument, the first argument that's passed to the shell script. In this case, I'm passing one argument called Rakesh, and it print, instead of hello $1, it prints out that hello Rakesh, and then followed by there is another variable called 0, which if I dereference it with the $sign, essentially it prints out the file name, what file name I passed. This is the file name that I use. So that gives the file name that has been passed. And then I have number of arguments that are passed can be, we can get that from this. In this case, I have only passed one argument, and it says number of arguments passed is 1. And this specifies a list of all the arguments that have been passed. Let's say if I say something. Oh, sorry. So I pass 2 arguments over here, and you can see that it prints out the first argument because that's what I asked it to print. And it says that I passed 2 arguments over here because that's dereferencing to this. And here it specifies that these all the arguments that we have been passed, which is the complete list over here. This will be a space separated list, essentially. In addition, you can also use if statements and for loops as well. Like if I look into it, if it is 0.04. So you can specify that, you can use if-else statements, which is in this particular order, saying that in here, I'm just mentioning that, did I pass this argument? Does $1 exist? That's what /z specifies. If it doesn't, it says that no arguments have been specified, or it says if I have specified it, just print out the first argument. And you can see that you can use conditional statements, and there are certain flags that you can use with the conditional statements. You can check whether a file exists, or you can check whether an environment variable is declared, and so on and so forth. In this case, .z specifies that is this argument specified. If I don't pass any arguments, it will print out no arguments. This particular flag checks if a file exists or not. If I passed an argument, if that file exists or not, I can check it using the -f flag. And lastly, we have array loops. And you can create an array with the space separated list over here. In this is a simple case. And you can loop through this array and print it out over here. If I run this particular command, so I declared an array 1, 2, 3, 4, and I'm looping over this array and storing it in my variable. and printing out that variable to the screen. If I do that, let's see what happens. So it's taking each individual string at one that is separated by space into this my var and just printing that each string to the screen. And that gives you a quick introduction to shell scripting. There is more to shell scripting than this, but like in an introductory course, that's what I wanted to cover, just to give you a functionality of what's available in the using Linux command lines and shell scripting. I've compiled all of commands that I used in this particular slide, and you can use this as a reference. You can just take a printout of this, and when you're initially starting out, probably after you go from this workshop, you will not remember half the commands. At least I didn't. And in order to get used to it, get a Linux system, get access to a Linux system, and start using commands. Start using the command line. Eventually, you'll find you'll get used to the commands, and they'll come more naturally as time goes along. But it will be overwhelming at first. Probably just take a printout of this particular slide, or you can find many resources of similar format online, and just keep a printout, and you can access it using that. Okay. Before we go, I just wanted everyone to copy this course material to their local directories. So the way I'm going to do it is I'm going to do a last demo, and you can follow it along as well. And you have access to these accounts until mid-November. Probably do it before that. So I'm in my PowerShell, on my local PowerShell, and I'm cding it to documents. You can copy it to somewhere else as well, and you can copy the course material that we have, which is given in this particular file. So first you need to specify the address where you want to copy it from. So SG1000. You can replace it with your own username. That's the server address and your username, and followed by the address, the location of the file, and followed by the destination. So that should essentially copy it onto the cluster, onto your local machine. There are other ways of doing it as well. Probably you can type in if you see over here, I'm just typing it so that once you do this command, that will essentially download the tar file. Yes. So that downloads the file to your local directory. And if I go to my documents, I can see somewhere. Yeah, I have the tar file, and you essentially have the files that you want. I'm little over time. That's the end of my presentation. If you have any questions, I'll stick around, and I can answer any questions that you have. If if anyone is interested, these are a couple of references that you can use when you're getting started out, starting out with Linux command line. And thank you for your time. Although they are set at two different paths, they are essentially linking to the same files.